shared responsibility and a holistic approach, which leads me comfortably into the subject matter of the next speaker, Micheal Beaven. As I said, Mike is sitting in for Alistair Guthrie, and Alistair has been a great advocate of a holistic approach to sustainability. I sincerely trust that I've been sitting in for him, that Mike's going to talk about a holistic approach to sustainability as well. So please welcome Micheal Beaven.
Thanks, Alistair. It's always hard sitting in for someone giving their paper. Alistair Guthrie's been kind enough to let me embellish a little bit. So, okay, when this is an advert for Arup tall buildings. What I do this up for is we always have buildings near waterfronts. I do wonder, even with the more conservative predictions of sea level rise with climate change, how that might look in 50 years' time. We can build just about anything now. We can use our technologies, our analysis, our techniques to build just about anything. And when you pick up on Aviva's speech, what shall we do with this knowledge? Shall we build more icons? We need some icons, but we need more icons. How many can we handle in our cities? Or shall we go for perhaps a more sensitive and responsible approach to our place on the planet and our potential for damaging it? What we shouldn't be doing, I don't think, is doing the same thing we've done for the last how many years in constructing our future. The Victorians, when we look around us and our polluted environments, what we're doing to our atmosphere, the Victorians thought slightly more forwardly perhaps, and thought underground to create a slightly less deadly place for their inhabitants. And this has been a real lesson in infrastructure, being the opportunity to make things happen in a better way, to reduce contamination and to improve the lot of the people above ground. And we see lots of pictures of things above ground, as an engineer below ground also interests me. We had a vision in the 60s of lots of tall buildings. A slightly less flattering picture of Chicago from this morning's talk. This is the city of the 60s we have now built, and we're enjoying for all its wonder. And we see the CBD here and suburbia that Peter used to test, stretching out into the far distance with all those motor cars going backwards and forwards. We see unsustainable urban growth in these ways. We need to change the way we are building radically to make a more sustainable future. And is that a future for us all? Is this a preeminent future we all want and we all desire? When we're looking at buildings in this context, and I see this as very much a contextual image, we have LEED and other excellent metrics for building greener. But really, when we're building greener, do we look for a tick list to achieve a LEED rating, or do we try and maximise the sustainability of any particular proposition? So we see we might do some of these things, but really it's not good enough, looking to the future, what we need to do to mitigate this carbon. So are we after green buildings or more sustainable development? It's a very big question. Sustainability, rather than green, contains a lot more stuff in it, particularly societal impacts, societal elements. And these vary in different ways wherever you are in the world. Some are common. Climate change, other issues and elements are common throughout the world. Others are more regional, water, for example, climate, microclimate, and then local, cultural. All have a reputational issue. And for those of you who are interested in reputational issues, Gary Lawrence's talk tomorrow afternoon is what I strongly recommend in terms of addressing the ability and sustainability to contend with reputational issues. But good questions for green buildings. I'll do the easy one, natural resources. This is a framework tool that we use in some of our projects in Arup. Within this can sit LEED, BREEAM, Green Star, other green metrics. This is a framework that helps our bigger urban projects to realise a bigger, broader agenda, as it were. And it's very useful to categorise our impacts and our opportunities for, as Alistair said in the first sentence in a way, where we have challenge and opportunity to do better. So natural resources is one part we look at. This conference is mostly about these topics, I think, in energy, materials, waste, water, those topics, which are specific to a plot, an individual element that have threads moving out. But of course, tall buildings, as I'll talk about in a minute, use more stuff per square metre than any other building type. They've got to have something else that makes them sustainable. A low-rise building, the Platinum building described in the previous presentation, is a low-rise building. Why would a high-rise be better? Why would it be greener? It's all about density. So we look at energy consumption. These are Hong Kong high-rise buildings. The higher the building, the more energy per square metre it uses. We can mitigate this by techniques, a conventional approach. With some high-rise buildings, this is the Shard in London, has multiple uses within it, sometimes called a vertical city. One wonders what the social demographic would vary from top to bottom in these particular cases. Offices, hotels, residential, we can mix and match, we can share the energy, we can do all sorts of things with this to mitigate energy performance, and we should. Combine heat and power, those sorts of mechanisms, energy that's liberated from air conditioning offices to heat or hot water for residences and hotels. These are opportunities we should harness within these mega structures, these very tall buildings. Wind is another classic high-rise topic, whether it's for natural ventilation, the velocities we can manage at high altitude, or for wind generation. Again, a very favoured topic, as the previous talk in the next room was discussing. We can actually ventilate buildings in Melbourne, in Sydney. This one's an interesting one, mainly air-conditioned, I have to say. One I worked on many years ago, but has naturally ventilated rooms, offices, and meeting rooms. They seem to be successful in their functionality. So in a climate which is suitable, we can mitigate by natural ventilation. In some climates, and this one, it's very difficult to naturally ventilate realistically. Not just for the air temperature, but for the dust in the air as well. So again, it's a local solution to a particular problem or challenge. And we can use quite well-tested techniques, naturally ventilating single pane, single layer constructions, double layer constructions. And these techniques, the higher you go, the more important it is to buffer wind effects and natural ventilation. A building in London, not particularly high-rise, but addressing these issues. It looks very glassy, only has 40% glass, a vision panel within it. So again, there's an aesthetic which is glassy, but the heat flux through the window is reduced significantly by having more solid, frankly. It's not that difficult architecture to deal with. It is difficult when you have a bright external environment and all glass, all the blinds go down, the lights go on, your energy consumption is severely damaged. And the technologies are well proven. This allows, unlike the German double wall systems, which have to access the inside to clean them, you can do it from the outside if you want to. We also test them to death. And the construction seems to be successful in its operation of the windows in a breezier, professional environment. And of course, gardens in the sky. A very common thing now, and of high value to occupants. Financially as well. This building, there was actually a ratings war for the floor that accessed this greenery. In the highest rent in the building for that one floor with access to greenery. So again, this thing about value is real. Now, facades are talked about as PV opportunity, and that's true for the latitudes further north. Of course, the higher the sun in the sky, the less valid they are. But as you shade buildings in high latitudes, the more overshading happens. Now, in a real case of this, these two buildings, the one on the right shadows on the left and eliminated the potential for any PV on the facades that the design team were keen to implement it. The only bit we could put on the roof of the left-hand building. These are real concerns when we develop high-rise very densely. The dream of energy production on buildings becomes anathema, becomes a nonsense in reality. But we can do a lot to reduce energy consumption of buildings. This is another building that uses tilted glass to turn away from the sun. Again, it's not 100% glass, so the vision panel with the external cladding is actually fully glass. We tilt the windows away and we save 20% of the carbon emissions that the perimeter office would emit through just that one move of tilting glass away from the sun. Again, the higher the sun in the sky, the more effective this can be for self-shading the buildings. Material use, again, part of the sustainability debate. We get taller, we get wind bracing. When we get taller, we put wind turbines on as big sails to catch the wind, which of course put enormous forces on the structure. So the green wind bracing bit goes up. Certainly in terms of when we address renewables on buildings, I think it needs to be realistic in how we deal with them. And the steel weight with a high-rise building goes up and up. The gravity is the blue, the wind force is the yellow, and again the higher you go, the more wind force you get, the more opportunity for generation. But is it real? What's the real answer? So really, I implore honesty in the industry for the real energy savings we have from renewables by putting wind turbines on tall buildings. When you brace them to take the loads, when you've isolated the vibration, When you caught all the wind you can, how much do you really get? And how long is the payback period of energy that you would otherwise save? We hear stories of people saying that, oh, this building will be carbon neutral because of its power generation. But in the end, it may produce 3 or 4% of the building's energy. Is that good value when there's more at stake than bolting something on a building? We did it for a low-rise building, and even a low-rise building, we took the turbines off and put them on masts because of the impact on cost and structure for putting them on the building. That's a low-rise building without the inherent overburden of wind pressure tall buildings have. The environment, a broader issue here. We talk about transport, ecology, air quality, external air quality. And again, we looked at our own offices, one in London and one in the regions, and that's a commuting pattern. The pink on the top is cars, the rest is public transport. And yet, when we analyse the carbon footprint of those, bearing in mind that London commuters come from an awful long way away compared to a regional office, the carbon impacts are about the same. So there's a little bit of a fallacy here about how far you travel into work and your mode of transport and the carbon impact, the carbon efficacy of that particular mode of transport. So again, where you are, what kind of city you are, will have an impact of the overall carbon footprint. The concentration that Peter mentioned this morning of cities, the diversity, the vitality. If there isn't diversity and vitality very locally, then all this is for now. The carbon impact will not change from a regional or sub-regional model. And again, we look at vertical cities, but how real is the movement between the commercial space and the public space within that building. And these are some plots that the UK government published on different modes of transport. On the left it's actually it's in carbon per mile. So left-hand side is personal transport and the railways in the middle, but they're not. It's only 2 or 3 times difference. There isn't 10, 15 times, sometimes the sense of the communication would have us believe. So again, some realism in terms of commuting. Now, whether it's a mega city where people commute for miles and miles, for 10s or 20s of miles to work, or whether it's a neighbourhood or a nodal city where there are many nodes around a central point. And this again is driving some of our city urban designers to think about multi-centre cities rather than a single mega city where people travel great distances to work and have an overall carbon footprint that makes it significantly worse. Now, economics is not my speciality topic. Efficiency is, and when we talk about design and talk about making high-rise more efficient, lifts, for example, come into the equation as a structure, and different techniques to reduce the amount of area. And yet, we still see the efficiency getting worse and worse the higher we go. Although it tends to stabilise out to about 30 stories, yeah, that's the same much as the Skylab is going. But again, efficiency is not why you do this, not why you build high-rise. And lastly, the societal issues. Again, inclusion, those are the issues. The inclusion one particularly, an important one for construction as well as for occupancy and the community. Again, it's a reputational issue in different parts of the world for the construction labour and how we build our buildings as well as how we occupy them and their societal benefit for the community. So to think, why are we going upwards? Is it cost effective? Only when land values are high. Is it saving the planet? It's not implicit unless you make it viable for where the building is. But is it about society? Is it about social inclusion? Again, it's not self-evident when we buy that we are not building elitist buildings, dare I use the phrase, or buildings that are not suitable or not friendly to the society within which they reside. I noticed on the Chicago tour, many of the buildings that people enjoyed being around were short buildings, not tall buildings. And in the Windy City, as Chicago is called, of course the microclimate around the tall towers can be extremely hostile. Is it to be the peacock, the icon, regenerating symbol? Very powerful, very important, not to be underplayed. But what is the real reason why we push upwards? And is it a catalyst for the city, or is it an ivory tower? Do we take our tube to work, stay in our building and go home to our obviously hideous suburbia? Or do we stay in the city? Do we move around the city as a part of our society, part of our culture and community? Again, that remains, I think, unproven. There's some questions there. When we master plan for large areas, we tend to have tall buildings in small areas. This is a new generation in London called Stratford City. Actually, the Olympics partly will be in 2012. And on that site, high density near a big transport node, the main rail to mainland Europe, concentrates around a node. There are a few tall buildings which have a very high intensity of occupation, but generally around it is, you call it medium rise, 10, 15, maybe even 20 stories, medium rise buildings. high concentration, high diversity, and many activities within that close locale, so people can enjoy their life in the city, live there, work there, and play there as well. So again, using many models. When we have got a fresh slate, this is what we do. When we haven't got a fresh slate, when we have a plot of high value in a city, how do we resist the temptation, if it is inappropriate, to whack a big tall building up? It's a very difficult conundrum, but we need to engage the difficult questions. So, we've got a greater density. Is with less transport? Maybe. Less infrastructure? I'm not sure. Urban vitality? Well, maybe. So really, I summarise, I suppose, with a series of questions. That where tall buildings are placed in the right place for vitality, in the right way with environmental governance, so their overall footprint is reduced, and connected to people, not seeking to do something that is elitist or separatist in terms of the cultural diversity of the city, then they can be sustainable from the ground up.